Hello everyone, this is Prashanth. Let's continue with the last lecture. In the last lecture, just I have completed some question bank discussion on the various sensors like USB sensors, embedded sensors, and ultrasonic sensor. So, what are the main specifications of these sensors? Specifications, applications, advantage, disadvantage, real-time projects, like that. Just we discussed in the last lecture. Now continue with the question bank discussion on the controlling hardware and sensor here. What are the controlling hardware and sensor with the just introduction point of which type of sensors we use. So here the what is sensors and what is actuators here. Sensors is nothing but there are the eyes of ears of the IoT system. They can collect about the physical environment such as temperature, light pressure, or motion. This data is converted into electrical signal that device can understand. Actuators, these are the hands of feet of the system. They can take proceed the data and use it the control physical devices. Just for example, turning, including the turning on lights, adjusting thermostat, and opening and closing waves. So these are the what is sensors and what is actuators. So here the first point here, the first point sensors and actuators. The second point is microcontrollers and single board computers. So here what is which type of microcontroller just we can use, like Atmel AMT2302 or whatever different versions of microcontrollers available to use to develop the IoT projects. So here there are small low power computers that act as a brain of the IoT devices. These are responsible for first reading and processing of the data, making decisions based on the data, sending control signals to the actuator. So these are the four responsible for data microcontroller and single board computers. Next, communication protocols. So after receiving the data, just we have to send the information from particular point to particular destination. So by using with the help of Wi-Fi, Bluetooth, cellular networks, and specialized low power protocols like Zigbee or Jetwave. So these are the some communication protocols in order to send the required data to the particular destination part. And fourth point, control cloud performs. So in order to processing the data, we have to store it in cloud. So for that, the platforms can be used to store and analyze sensor data, send control commands to devices remotely, and manage large number of IoT devices. So here are some ways hardware control is achieved in IoT system. Direct control, cloud-based control, and mobile app control. Here users can control IoT device through the mobile app, which sends commands to the cloud platform, which then relays them to the IoT device. Sensor data is sent to the cloud, analyzed, and control commands are sent back to the device, to the instructor of the actuators. So next one, examples of hardware control in IoT. Smart thermostat and adjust temperature based on the sensor reading. The first one, smart lights that can turn on and off automatically or can be controlled remotely. That is the second next one. And wearable fitness trackers that monitor heart rate, steps taken, and calories burned. And the last one, industrial automation system that monitor and control the machinery. By understanding these principles of example, you can see how hardware control is essential for enabling IoT devices to interact with the physical world and provide functionality and automation. Next, this one first device that is controlling LED, connected LED. Connecting LED, an LED is nothing but light emitting diode. Is a functional building block for many IoT projects, providing a simple visual indicator. Here's how to connect a device LED to microcontroller in the context of IoT. So what are the materials to in order to connect? Breadboard, jumper wires, LED resistor for 220 ohms, a common value for LED, and microcontroller board like Arduino Uno and Raspberry Pi. So these are the two microcontrollers just we need. So these are the materials to connect the device. Connection type. So which type of connect? Just identify the LED LEDs. For example, this is just LED. Just you can connect plus minus anode and cathode. Connect to the resistor. This is the resistor based on flow of current. Just we can initialize. Connect resistors. Connect LED. Connect to positive and negative nodes, and connect the microcontroller to the power. So these are the connection type of connecting LED. And programming the control platform. Just first you can choose the platform, and the programming language and environment will depends on your microcontroller board. Arduino IDE. IDE stands for Integrated Development Environment. So Arduino IDE just we use to it is a common platform to write the code and basic LED control just by using C++ here. This is the code for programming to the controller, and program the control just it is the close function. Upload the code following your platform's instruction. Upload the code to your microcontroller board, and observe the LED. If everything is connected correctly, the LED should blink off on and off for every second. Just we can give 1 second for the waiting that LED on or off. For every 1 second, just the LED blink on and off condition. So the explanation part we already know. The pin mode function configuration. Choose the pin, for example, pin 13 as an output pin, allowing microcontroller to the control of LED. By experimenting with the LEDs, you can gain valuable experience with essential components used in the many IoT projects. So these are the explanation of connecting LED on the breadboard. And buzzer, second one, buzzer. So it can give beep sound for beep sound for every 0.5 seconds. For every 0.5 seconds. The principle of IoT, the buzzer is another fundamental output component alongside LEDs. It provides a simple audible way to indicate events or status. Here a house buzzer can be connected and controlled with a microcontroller board that can use. So here we need some materials: breadboard, jumper wires, buzzer, resistor, microcontroller board like Arduino Uno and Raspberry Pi. Next to connection, identifying the buzzer type. Which type of buzzer just we may use? Passive buzzer and active buzzer. Passive buzzer requires a DC voltage and resistor to limit current. The specific resistance depends on buzzer's voltage rating. A common value is 100 ohms. So the 100 ohms. And active buzzer contains an internal oscillator and requires only a single power supply, that is ground and VCC. Connect to the buzzer. Passive buzzer similar to LED connection with resistor, and connect to one leg to the just the following same instructions to connect to every device on the breadboard. And here connect to the buzzer, active buzzer. Connect one leg to the buzzer to the power pin. Just the explanation as usual. And programming to the control. Just choose your platform. Just Arduino IDE. We need to use Arduino IDE. Basic buzzer control code. Here simplified Arduino code snippet to aggregate a deep with a passive buzzer. And this is the C programming to encode to. This is the C program to dump with microcontroller. Just we can do it will give 0.5 milliseconds of delay for every 0.5 seconds of for every 0.5 second the buzzer it will give beep sound like that. And buzzer, upload the code, observe the buzzer. If everything is connected correctly, you should hear the buzzer beep repeatedly for every second. So this is the explanation part for connect the buzzer. The basic example demonstrate how to use a buzzer in IoT application. You can expand this playing different tones, playing at different tones melodies by adjusting the timing of the digital write commands and off cycle, using the buzzer along with sensor data to provide audio cases based on sensor readings like buzzer beeping faster as temperature increases, like that. Controlling the buzzer remotely using Bluetooth or Wi-Fi communication for remote notifications, like that. These are the buzzer, some real-time examples in the IoT. And the last one, switching high-power devices with the transistor here. Understanding transistor act as like electronic switch. It has three terminals, emitter, base, collector. So this is the a transistor like an electronic switch. So this is the emitter, this is the base, this is the collector. So by we are applying input through the base, collecting output from the collector. This is for biasing purpose. The emitter is just by maintain the by applying a small voltage to the base terminal, you can control the flow of a much larger current between the collector and emitter terminal. So next types of transistor, just we have bipolar junction transistor, and field effect is not field effect, it is unipolar transistor. Unipolar bipolar junction transistor and unipolar junction transistor. The main difference between bipolar and unipolar is bipolar is nothing but bipolar junction transistor is the flow of current due to the either flow of current or flow of electrons or flow of holes in a device. Or unipolar junction transistor, the flow of current either may be due to the hole moving of hole or moving of electrons. So that is the main difference between bipolar junction transistor and unipolar junction transistor. BJTs are again NPN transistor and PNP transistor. So there is no need of explaining complete explanation for this transistor. Just we have to know what is the controlling of devices here. Types of transistor, just you have to know, that is okay. Switching high power devices, it is operates at low voltage, that is 3 volts to 5 volts up to, just we cannot provide enough current to directly power high power devices like motors, solenoids or lamps. And applications of IoT in IoT, controlling motors, switching lights, solenoid activation transistor can control solenoid used in valves or other actuators in IoT system. Some safety consideration also we have to follow. Main power requires caution and following electrical safety guidelines. It's recommended to use pre-built driver modules or consult a qualified electrician for high voltage application. That if you use high power application, compulsory you take some precautions from the electrician also. Just that is the essential part. Transistor have a current to voltage limitations. Choose a transistor with appropriate ratings to handle device you are controlling. So for this developing, just BSc 107 is the enough for us. As per my knowledge, BC 107 is the enough. This is the transistor just we may use in our laboratories also. BC 107 series number. Heat dissipation is a concern. Depending on the power being switched, heat sink may be required on the transistor to prevent overheating and damage. Next, limited learning resources here. Just you can type transistor as a switch or BJT for beginners. Will provide everything for us in the online. And last but one, controlling AC powered with relays also. The relay is nothing but controlling AC powered devices with relays is a fundamental concept in IoT applications, where you need to interact with devices operating on mains power. Here's a breakdown of how it works. The role of relays here: a relay is an electromechanical switch that uses a low powered control signal to control a high power circuit. It has a coil and contacts. When a voltage is applied to the coil, it generates a magnetic field that pulls in a metal armature. This armature physically opens or closes set of contacts, interrupting and allowing current flow in the high power circuit. So these are the main roles of relays to develop the IoT real-time projects. Why use relays in IoT? For maintain the safety of the IoT device, and power handling capabilities also increase. So the types of relays: SPDT and DPDT. SPDT is nothing but a single pole double throw, and double pole and double throw. So these are the two types of relays which are available to developing the IoT real-time project. So using real-time relays in IoT project to connect to the control circuit, connect to the AC power circuit and microcontroller. So these are the essential things to connect to the relays used in the IoT real-time projects. Connecting the control circuit, connect to the AC power circuit and microcontroller code. The next one, safety precautions while we are using sense relays in the IoT projects. So here the AC power danger is if you don't comfortable with electrical wiring concern, just you can contact electrician. Always double check your connections and ensure proper installation to prevent shorts, potential fire hazards like that. Use relays with a voltage and current ratings exceeding AC power or AC device you are controlling, and consider using the pre-built relay modules that integrate essential components like optocouplers, add safety and isolation like that. And benefits of relays in IoT. So here enables safety and reliable control of AC power from low power microcontroller. Offers isolation between the controller and AC power circuit, protecting your control. Provide high current handling capability compared to transistors. So these are the benefits of relays in IoT. And learning resources, just you can type controlling AC device with relays or IoT relay modules, like just you can everything regarding the relays. So these are the question bank discussion on the various devices like connecting LED, and relays and transistor. These are the three major topics. Just we hardware, control and sensor. These are the how to connect a device on the breadboard. What are the specifications? What are the applications used to develop the IoT projects like that. So remaining this is the lecture. 65 lectures on Internet of Things. Just you may use to develop your subject also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.